discuss the questions.
Progress.
Theory tude, the last 2 pages questions and textbook exercise of unit 2 physics, and we had to start today chemistry unit 3. The first lesson we had on biology, and second lesson we completed physics, and the third lesson we had to start today chemistry. And there were some students also join, the last week also some students. Any student joining today from the beginning, please raise the hand. Because otherwise they'll find it difficult to understand the questions I'm discussing under chapter 2. Therefore I'll start the unit 3, and then once they complete the theory note, at least so they have to then only they can understand the questions. Okay, so chapter 2 physics, we have done displacement time graph, velocity time graph, acceleration, deceleration, then calculations also from based on this motion graph, right? And so the third lesson chemistry I have shared with your WhatsApp group, theory group, PDF of the theory tude, chapter 3, unit 3. Please raise the hand those who are able to get a hard copy of this printout of the third lesson, new tude. How many of you got? Just to get the hard copy of, then it's easy to, otherwise you have to copy down everything. It takes time during the online session, so therefore you can complete only the blanks of that. Okay, around 12 to 13 students. Okay, good. Others you can copy down separately the page number, and only for the blanks you can write the answers, right? Okay, I'll share the screen now. Right, so this is chapter 3, unit 3, structure of matter. Right, you can see the screen now, structure of matter. So actually matter means anything that occupy space and has a mass. That means non-matter means no mass and they don't occupy space. So matter can be solid, liquid or gas. Matter can be solid, liquid or gas. And so non-matter means basically energy. So the non-matter means energy. Example, light energy, heat energy, electrical energy. So you can't tell I am receiving 1 kilo from a lamp, so it's not tangible. Light travels, but you can't tell this much of or this much of grams of light, so that is non-matter. So light is a form of energy, so that's why we discuss this under physics. And even heat energy. So when I talk sound energy also, that's non-matter. So but if you take gas that vibrate, gas molecules having a mass, but sound energy that travels, so that is non-matter. So sound energy, electrical energy, light energy, heat energy, they all come under physics. That is non-matter. But actually chemistry is the field of the study of matter and the structure of matter. So if you take anything around us, so any tangible thing, anything with a mass and that occupies space, matter, and they are made of the basic unit called atoms. So that's what we are going to discuss today, the atomic structure and how they look and where are they found, and what consists of these atoms. So therefore the chemistry, this is the first lesson you are going to start grade 10 syllabus, the chemistry. And if you don't understand chemistry the first lesson, then you will find it difficult to understand the other lessons also. Therefore you have to pay more attention, and you should not miss anything in the chemistry and physics, because if you miss one lesson, then it's difficult to understand the rest, right? Okay, so I'll discuss with parallel to this third lesson, I'll discuss the questions of the previous one also. I think some of the students, they need time to finish it because some they joined recently the class. Okay, so if you take now, I'll share the screen again. I'll go a small summary of this matter. I'll share the Zoom whiteboard, right? Okay, you can see the screen now. Look at the screen. Okay, you can copy down the summary in your writing book. You can copy down the summary in your writing book. Look at the screen, everyone. If you take matter around us can be divided into okay, matter means anything that occupies space. Matter means occupies mass, So it can be divided, matter can be anything that occupies space and has a mass. Anything that occupies space and has a mass. Or else you can write things that occupy space and has a mass. Things that occupy space and have a mass. You better copy down this in your writing book, the summary or the introduction to this lesson, and have a mass. Right. So therefore now matter can be solid or liquid or gas. So matter can be either solid or liquid or gas. Either solid or liquid or gas. You can divide matter into two main groups. Most of the things that you find around us. So this is unit 3, the summary, or this is the unit 3 chemistry, the summary. Introduction to the lesson. Now you can divide matter into two main parts. Number one, two main groups. First one you can write pure substances, pure and mixtures. Look at the screen everyone. So certain things around us, it can be a solid or liquid or gas, it's pure. If it is not pure, that means non-pure means it's a mixture, more than one component. Consists of only one component, it's pure. And if it is more than one component, it's a mixture. Two or more, combination of two or more components. Combination of two or more substances called mixture. What is mixture? Combination of two or more substances. Combination of two or more substance mixtures. Example, dal and rice, or water and alcohol, or sugar and water, or salt and water, salt solution, sugar solution. Two or more substances. Combination of two or more substances. So if it is only one substance, consists of only one substance, that is pure. Consists of only one substance, then is pure. Consists of only one substance, that is pure. So pure substance, again we can divide into two groups. Everyone please copy down this in your if you have a CR book, it's easy to copy down. Separate you have to copy down this. So you can divide this again into pure substance can be divided again into two groups, that is elements and compounds. That means, I'll give one example. If you take 100% pure gold, so that is pure substance. So elements or compounds. Elements or compound. Example, water that you drink. Actually water that you drink, it's not pure. Drinking water is not pure. Why? Because it contains dissolved minerals, dissolved gases. Tap water contains a lot of minerals. So that's why we used to say mineral water bottle. Mineral water contains minerals. Saline water, it's a mixture. Jeevani, mixture. It's not pure. No one is drinking 100% pure water. Water that if you drink 100% pure water or ultra pure water or deionized water, you will die, because your body requires not only water, essential minerals or electrolytes. That's why a patient in the hospital not given a water bottle is connected to their blood. The nurse will not connect water bottle. It's saline. Why saline? Body requires not only the lost water should be replaced with ions. So due to vomiting or loose motion or excessive sweating, Remember, you are not losing only water, you are losing some essential minerals. Grade 10 chapter 1 you have done, no minerals, sodium, potassium, calcium, magnesium. So those minerals are required by the body. That's why it's very important. Even sweat contain not only water, essential minerals. So you're losing from your body, you have to replace them. So therefore, water that we drink is not pure. So most simplest method to identify whether it's pure or not, if you can write a chemical formula. If you can write a chemical formula, then say example gold is Au, that is pure, right? Gold is Au. Then if you take say copper, so copper you can write the symbol Cu on it, consists of only copper atoms, nothing else. These are elements. If you take here even oxygen gas, right? Oxygen say O2, right? So they are pure, they are elements. Even if you take silver, what is the symbol? Ag silver, Cu copper, Au gold. So these are elements. If you can write a chemical formula, we call them and if it is only one, it's made of only one type of atom, so they are called element. And the other one is compounds. Compound consists of two or more elements and compounds. Example, water that you drink, say copper sulfate, sodium chloride. Please note down this at the same time in your so I'll write here examples. Here I'll write examples. Say I'll write example, glucose C6H12O6. So this is glucose, it's a monosaccharide, that is compound. If you take say water, or if you take copper sulfate CuSO4, or if you take sodium chloride NaCl, this is water, copper sulfate, then sodium chloride, they all compound sodium. So if you can write a basically, if you know the constituents or the composition exactly, so it's pure. And it's only made of sometimes, because sometimes you might argue, so why there are three elements, how can it become pure? Actually, even though there are three elements in carbon, hydrogen, oxygen in glucose, they are chemically bonded. So water H2O, can you take a knife or blade and cut the water molecule like this? Can you cut this with a blade, or can you break this water molecule into oxygen and two hydrogen atoms? By crushing, grinding, breaking, or by any other physically, you can't do it, because they are chemically bonded. So wherever in the water, you can't tell Sri Lankan water different from American water. Water is H2O anywhere in the world. Water boils at 100 degrees Celsius, is colorless, odorless, tasteless, non-polar, polar inorganic solvent. So the properties won't change with the country or with the region or with the place. And the chemical composition, say example water, hydrogen to oxygen ratio 2:1. Either you take liquid water or water vapor or ice, so it's H2O. So it's with the physical state, it won't change the formula. So those things are very important. That's why it has definite properties, definite chemical composition, compounds. So that's why we call it pure. But if you mix water and glucose, so glucose solution, then is a mixture. So combination of two substances, right? Combination of two or more substances. So example, glucose mixed with water, or salt, sodium chloride mixed with water, salt solution, then it's combination of two substances. Actually, if you take tap water, it's a mixture. It's a mixture of what? Water plus minerals plus, there can be even microorganisms in water, plus you can take gases, the dissolved oxygen. When you open the lid of the bottle, atmospheric oxygen, dissolved gases present in water. So it's tap water, drinking water is not pure, it's a mixture. Fruit salad mixture. And even if you take this, please raise the hand those who are saying this. You might have heard in jewelry shops or even jewelry, so they use here 22 karat gold, 24 karat gold, 18 karat gold. So are these pure? Please raise the hand. They are pure gold. We use these jewelries with 22 karat gold or 24 karat gold. You might have seen this, right? Definitely. So please raise hand. They are pure. Please raise the hand. 22 karat, 18 karat gold, or which is 22, 18. So they are mixtures. It is pure. Okay, Kishan. Okay, very good. Okay, most. Okay, right. Okay. So can anyone tell me it's a mixture of what? This 22 karat or 18 karat gold. If you know the constituents, elements, or composition, yes. I'll ask from the Sandusha. Yeah, it consists of what elements? Sandhi?
Copper. Copper.
Yeah, very good. Yeah, in addition to gold, it's copper is also present. Yeah, very good. Yeah, those who raised hand, very good. It's consist of, it's a mixture of, they all mixture of copper and gold. So gold, the symbol is AU, right? Why it's why copper is added to gold and convert this? That means the alloys. All these are alloys. Mistral alloys. So it's an alloy of copper and gold. Why copper is added when making jewelries from gold? Why don't we make those jewelries only from gold? Why copper is used? Why it is an alloy? Why it is converted into an alloy? Any benefit we get by adding copper? Because the 18 karat gold is less expensive than 22 karat gold. 22 karat gold is less expensive than 24 karat gold. Can anyone suggest what is the reason for adding this copper, mixing copper with gold when making jewelries? And that carat value increase means price increase. Yes, Bhatika?
Because gold is high.
Gold is high in the sense, Bhatika.
Means I am telling gold is highly flexible.
Yeah, okay. Actually, gold is not strong enough, right? So the strength or the it's not it's, so the to increase the strength, right, and the to improve the properties, alloys are stronger than the pure metal. That's the reason. So otherwise, if you make only from gold jewelry, it will easily break. So yeah, I think you also suggested the same idea you gave. That is the reason, right? Then in addition, okay, now you can understand it's a mixture, right? 22 karat gold mixture, air that we breathe mixture. Yeah, don't write it. Because this mixtures also we have to classify again. Don't write here. You can write separately. Yeah, we breathe. 22 karat gold. They all mixtures. And then water. Water that we drink. Water in the sense like drinking water, or see rainwater, or drinking water, or tap water, or mineral water. Saline, they all mixtures. Saline water, Jeevani, right? Other than that, my next question: air that we breathe, mixture or pure? Why it is a mixture? Are we breathing pure air or mixture? Oh, air that you inhale now? Yes, Vishwa, it is Satsarani.
Mixture.
Yeah, it's a mixture of different gases. Correct. It's a mixture of different gases. Like what? Oxygen, nitrogen, right? Carbon dioxide. Now these days you inhale more carbon dioxide because you are wearing the mask. So sometimes exhale again you inhale. So therefore your blood contain more carbon dioxide. That is not good to our health also. Sometimes you get headache and like vomitish feeling because of the CO2 level increase in blood, and blood can become slightly acidic, pH value. Oh yeah. So that's about air that we inhale. Now I'll ask next one. What about if you take say okay, I told now this 22 karat means any alloy, right? Any alloy is, it's an alloy. Alloys are mixtures. Now next one, what about okay, you might have definitely if you take a Tipex. Tipex, if you have a Tipex in your hand or in your pencil box now, please raise the hand those who have got a Tipex in the with you now. Correction fluid or Tipex in your pencil box at this moment. Take it out and look at the label, everyone. Correction fluids or Tipex. Correction fluid or Tipex. So you can see it, you get tick. You have to shake well before you use it, no? Shake well before using. Shake well before using. I'll come to that later. So it's a mixture. Why? Otherwise, without shaking the Tipex, if you apply, so only like water like substance coming out, not exactly Tipex. That's the reason. So it's a mixture. And if you take most of the medical syrups shake well. So Tipex or correction fluid, medical syrups, cough syrup. So they are shake well the bottle before drinking. Why? Even Milo packet, milk, Milo packet or milk. So they has to shake well before drinking. So when you shake well, it becomes what? Homogeneous. So it's the composition becomes same throughout. Otherwise, you are drinking only the solvent, not medicine. If you shake without shaking, if you are drinking the cough syrup or the medical syrup, you are drinking the solvent floating at the top, not the medicine. Therefore, shake well means it's heterogeneous. So that means composition. So that means mixtures we can divide into two groups. Okay, I'll write here. Okay, now you can complete the rest here. Mixtures can be divided into two main groups. What are the two main groups of mixtures? Right now, mixtures, there are two types: homogeneous and heterogeneous. Homogeneous and heterogeneous. Please copy down this in your writing book under the heading Unit 3 Chemistry, Grade 10, Unit 3, third lesson. So what are the two types of mixtures? Homogeneous and heterogeneous. Heterogeneous. So I told you shake well means what? It's hetero. Composition are not same throughout. Homogeneous mixtures and heterogeneous mixtures. If composition same throughout, or from place to place composition same throughout, then we call homogeneous. Example, glucose solution. Particles are not visible anyway after dissolving glucose in water. Glucose solution homogeneous. Or sugar solution homogeneous. Or you dissolve sucrose or any disaccharide you dissolve in water, so it's homogeneous. And if you take alloys like what? Brass, bronze, duralumin alloys, you can write some examples within bracket. Say bronze, or even 22 karat gold. What gold? 22 karat gold. They all alloys. 22 karat gold. So they are mixtures, but composition same throughout. The quality is good. When you look at the bracelet or chain, you don't see the copper atoms and you can't distinguish the copper atoms and the gold atoms. Gold atoms you can't distinguish from the copper. So that's throughout the chain or throughout the bracelet. Appearance same, color same throughout, from top to bottom. Or throughout the solution, appearance, color, density, concentration. So those properties won't change. So we call them homogeneous. Even air that we breathe, you can't tell, okay, my room, I am getting more oxygen than in one corner my room, I am getting more oxygen than the other end. You can't tell like that. So in your room, composition of air same throughout. You can't tell this corner more oxygen than that corner. So oxygen concentration same throughout. But if you move away from the earth, the composition will change about 10-20 kilometers away from the earth level. So if you are moving away from the earth, then the composition will change, but the same level. At the same level, the composition of air same throughout. Air that you inhale, 78% nitrogen, 21% oxygen. Therefore, atmospheric air also homogeneous. Air also it's homogeneous. So what about heterogeneous? Heterogeneous means you can write example, say medical syrup or fruit salad. Fruit salad is, that means particles are visible to our naked eye. In heterogeneous mixtures, particles are visible to our naked eye. there's a video also, I'll show that later about this homogeneous and heterogeneous mixtures. For after once you complete this copying down, I'll show that also, right? I'll show that video clip also, then it's easy for you to understand what are mixtures. Okay, then right here under heterogeneous mixtures means what? Composition, not if you want to write separate, but anyway these mixtures you will be discussing in grade in detail under grade 11, right? So it's in grade 10 you learn this side, and this grade 11 you learn this part. Therefore only the classification enough categorizing this, but in detail the definition of homogeneous mixtures, heterogeneous mixtures and all, you that's grade 11 unit 3. I put G11 unit 3 you will be doing. So this is grade 10 unit 3, you learn about elements and compounds only, right? Only about that, right? So that therefore mixtures, don't worry, you will be getting again in grade 11, but in the grade 10 textbook at the beginning they have given this summary classification, right? Then if you take soda, saline water, that is actually mixtures, but if you take it's homogeneous if the composition same throughout. So if you take alcohol solution, plain tea, so it's homogeneous, but milk tea heterogeneous. Plain tea you are not shaking while you are drinking, because it's homogeneous plain tea, but heterogeneous. If you take milk tea or fruit juice, that's heterogeneous, because from time to time you have to mix it well, no? So you can write here muddy water, that is heterogeneous. Muddy water, if you keep the glass containing muddy water for some time, particles settle at the bottom. So you can write here muddy water, that's heterogeneous. Or you can write lime and water. Lime means not lemon juice. Hunu lime plus water, heterogeneous. If you take rice and sand, rice you mix with sand, that is heterogeneous. You can see the rice part, the seeds among the sand particles, so that is heterogeneous. If particles are visible to our naked eye, it's heterogeneous, but in the exam mostly they ask about these elements. So this is what we are going to discuss under chemistry. This left side, the elements and compounds, you will be discussing under this lesson, and mixtures you will be doing summary. Please copy down this, everyone. Please raise the hand those who are still copying down this. Please raise the hand those who are still copying down this. Right, okay, when you are done, please lower your hand. When you are done, please lower your hand. You can quickly copy. If you have a CR book, it's easy to copy down. So this is a introduction to this third lesson. When you are done, please lower your hand. If you want to write just below homogeneous, you can write composition same throughout. Composition same throughout. Heterogeneous means composition changes from place to place. Right, okay, then I'll erase this. Right, I'll erase this, and let's move back to the theoretic again. So I have not given this in the theoretic because these are the basic things that you should know. So basically the easiest method to remember this, what if you can write a chemical formula for a given substance, so it's pure. But you know exactly the element present in it, in which ratio the elements have combined. But if you can't give a chemical formula, example mortar, badam, or cement is a mixture, or mortar, mixture. So if you take even tile, mixture. So if you take curry or fruit salad, they all mixtures. Plain tea, milk tea, air that to breathe, they all mixtures. So classification of this as homogeneous and heterogeneous, they will not test in grade 10 syllabus. They'll ask that in the grade 11 syllabus. Don't worry about this. If you are given a substance, if it's enough if you can remember whether it's pure or mixture for grade 10. But homogeneous and heterogeneous, you will be discussing this in detail under grade 11 unit 3 chemistry. Okay, now I'll erase this and let's move back to this theoretic. Okay, one more thing. Now there's a small video clip. I think I shared with you this periodic table. Okay, I'll share with your WhatsApp the periodic table also because right. Give me a second now. Mixtures. Right. Theoretic mixtures. Okay, now I'll show you a video about this mixture so you can just to have an idea. I will share the screen again, then it's easy. Okay. Okay, I'll share the screen again. Can you all see the screen? Please raise the hand those who can see the screen. Can see, right? Okay. Okay, right. Okay. Okay, I'll share the sound also. Then you can watch this to have some idea about mixtures. Right, I'll play it.
Mixtures.
Mixtures. Chicken soup, clouds, keto, mud, cereal, gasoline, blood, coffee, concrete, sand, your favorite soft drink, even the air you breathe.
Mixtures are a combination of two or more substances that do not undergo a chemical reaction. Mixtures can be any combination of solids, liquids, and gases.
Italian salad dressing, for example, is a mixture of all three.
You can see the herbs, the solids, and the air bubbles, the gas, mixed in with the oil and vinegar, the liquids.
The components of mixtures can be separated through evaporation, through gravity, or through other mechanical means. Mechanical methods of separation can be as simple as picking olives off of a salad, using a filter to clean the air,
Or using a magnet to separate iron filings from sand. Some mixtures can be separated utilizing specialized equipment. For example, a washing machine removes water from its load by spinning. Similarly, a centrifuge forces denser substances to the bottom by spinning a sample very quickly.
There are two kinds of mixtures, homogeneous and heterogeneous. These names are based on the Greek root words, homo meaning same and heteros meaning different. The components of homogeneous mixtures are uniformly distributed, whereas the components of heterogeneous mixtures are not.
Mixtures like oil and water, cereal and milk, and salads are called heterogeneous mixtures. The components in heterogeneous mixtures are unevenly distributed. Components may be as large as lettuce leaves in a salad, or as small as water molecules in an oil and water mixture.
One example of a heterogeneous mixture is when we put food coloring in mineral oil. The food coloring remains in the form of droplets that settle to the bottom of the container. The two components are not distributed evenly and make a heterogeneous mixture.
There are many different kinds of
Okay, now you can see this screen. I pause for a while. Look at the screen. Now when you take some solutions you can see here, appearance same throughout, color same throughout, right? So we call them homogeneous mixtures. Appearance, color, density. So this if you taste this, but if it is say salt solution, from bottom to top you get the same taste. So if you take plenty from bottom to top or top to bottom, you get the same taste throughout the when you're drinking this. So therefore appearance, color, density, concentration, that means from place to place. If I mark few points here, the color won't change. Appearance, so if I mark here 2 points A, B, C, D like that, so the color, appearance, all concentration, all same throughout. That's why we are used to say these are homogeneous. Okay, I'll play the video again.
forming a homogeneous mixture.
The food coloring cannot be distinguished from the water in the same way that dissolved sugar cannot be distinguished from coffee. Although they cannot be seen, both substances are still in the mixture.
There are many different kinds of homogeneous mixtures, including solutions and colloids. A solution is a homogeneous mixture whose components form a single phase. In the case of sugar and water, you can have a solid dissolved in liquid, but the outcome is a single.
So again, I stopped the video for us to explain this. Now you can see here this one also. Right? You can see here the say sugar solution. This one appearance from top to bottom, say sugar solution. If you take from bottom to top or top to bottom, appearance, color, density, concentration, taste, so same throughout. From place to place, if I mark here A, B, C, from place to place the composition won't change. That's why a sugar solution is homogeneous. Right? Composition does not change from place to place in the mixture. But if you take muddy water with time or maybe fruit juice, particles settle at the bottom. Medical syrup, the particles settle at the bottom. That's why you have to shake well before you use it. Example, Tipex, correction fluid, that is heterogeneous. That's why you have to shake well before you apply Tipex, right, for erasing something. Right, I'll play the video.
Colloids are mixtures where fine particles are dispersed throughout another substance and tend to have a cloudy appearance, like milk.
To recap, A mixture contains two or more substances that are held together by physical forces and do not create a new substance. Mixtures can consist of any combination of solids, liquids, and gases.
Mixtures can be separated by many approaches, such as evaporation, gravity, or mechanical means.
Mixtures can be heterogeneous or homogeneous. The components in heterogeneous mixtures are unevenly distributed, whereas homogeneous mixtures are evenly distributed. So now you know.
Right. This is like, to have a better understanding about mixtures. They have given this at the beginning. Okay, I'll stop this. Let's move back to the theoretic and the textbook. Right. Okay. Okay, you can see the screen now. And if you take the textbook, unit 3, at the beginning, they have given this summary. But they will never ask you to copy in the exam to draw this again. But you should know, okay, this is what they have given in the textbook at the beginning of this lesson. Right? Look at the screen. Sometimes they can give a small flow diagram, or which of the following is an element, or which of the following is not an element. They can give which of the following is not an element. They can give examples, 4 answers. MCQs, they can ask this. Which of the following is not a pure substance? They can give MCQ. So they can answer MCQ from this, right? So this is given in the textbook also, but you should know when you are given something, whether it's a mixture or not. That's it. Or pure substance. Non-pure means it's a mixture. Actually, most of the things around us mixtures. Most, even if you will never find 100% pure water. Even when you get 100% pure water, and when you open the lid, what happens? Imagine someday you might say we can now. I don't think you can even find this 100% pure water in the laboratory, even in a school lab. Why? Even if you take 100% pure water H2O, the moment you open the lid, so when you open the lid of this bottle, what happened? Gases, germs get dissolved. Oxygen gas get dissolved. Carbon dioxide gas get dissolved in water. Germs or the bacteria, microorganisms can get dissolved. Dust particles can get dissolved. So it become a mixture the moment you open the lid. Therefore, no one is drinking 100% pure water. That means 100% H2O you cannot drink, and no point of drinking even. So even saline water or even distilled water even contain dissolved gases. Right? Remember that. Okay, so that's about the introduction to the lesson. That's what they have given at the beginning of this. So these things are a bit important. Those who have not got the printout of the theoretic, at least in the textbook, you have to highlight these points. One is what? What is matter here? Matter means what? Things that occupy space and have. So matter important. So that occupies space and have a mass. Okay. So they are called matter. And matter we can classify according to the physical nature as well as chemical composition. Physical nature, what? We classify like this. Based on the physical nature, we classify it in 3 groups. Based on the chemical physical nature of matter, we can classify into 3 groups called solid, liquid and gas. Based on its composition, based on the composition, we classify them as homogeneous, heterogeneous, pure substance, mixtures, like that. Right? So that is the beginning, introduction to this lesson. Therefore, chemistry is the field of the study of matter and the structure of matter. Now let's move back to the theoretic again. Look at the screen. Now if you take this matter, what is the basic unit or the building unit of any matter? Look at the screen, highlight the word if you want matter. Any substance made of matter, any substance, whether it's solid or liquid or gas. And the basic unit or the build, I have highlighted here the basic unit. If you have got a black and white printout, you can, if you want to underline that, building unit blocks, or the, so you can write basic unit, or some we call it building unit. You can write that within bracket, basic unit or building unit of matter will be what? What is the answer for this? Atoms. You can write the answer. So I write the answer for the first one, blank, atoms. Atoms are the building units or the basic unit. Underline the word. I have given here within bracket basic unit. No need to write it again. But if you take the organism, the basic unit will be the cell. The organisms, the basic unit will be the cell. Okay. Then next one. If you take any atom, right, if you take atom, so actually this is how it happens. If you take okay, I'll use this white screen to then if you want can copy down this additional point in your writing book. Look at the screen. I'll use white background for additional explanation. Always everyone should maintain other. This is the theoretic, it will be the formal note. So I will be not be in a separate note in your writing book, but flow diagram, summary, concept map, mind map, like additional information I'll ask you to write separately in your writing book. But this is the formal note. When the exam is closed, you can quickly refer this note. So this is what I want to copy down. Now, if you take your body is made of what? Your body is made of various systems, right? Organism. So multicellular organism. Multicellular organism. So organism can be unicellular or multicellular. Organism. Organism made of what? Various systems. Digestive system, respiratory system. So systems. Right? Systems are made of what? Various organs. So your blood circulatory system made of heart, blood vessels and all. Organs. So if you take nervous system, brain, and the respiratory system, lungs, like so. Therefore, systems consist of organs. Organs. Then organs made of tissues. Organs are made of tissues. Tissues are made of cells. Tissues are made of cells. And cells are made of various compounds. So this is the turning point here. So cells are made of various compounds, say protein, lipids. So they are made of molecules. Molecules and compounds. Wait, I'll write before that. I'll write one more thing. Organelles. The cell consists of organelles like nucleus, right? I'll write here organelles. So don't mix up organs and organelles, right? You can copy down this also in your writing book. So any organism, multicellular organism, even your body consists of 7-8 systems: digestive system, respiratory system, blood circulatory system, nervous system, excretory system. So those systems consist of organs. Organs are made of tissues. So example, brain is made of nervous tissues. So the heart is an organ made of cardiac tissues, right? Like that. Then tissues are made of cells, and cells are made of organelles. Cells are made of organelles. So example, if you take animal cell, there are mitochondria, nucleus, right? Chloroplast, so organelles. So these organelles are made of beyond this. If you take this further, organelles are made of compounds and molecules. Organelles are made of compounds and molecules. They are made of what? Compounds and molecules. Right. So then you can write here, this is chemistry. Compounds and molecules. Compounds and molecules. So you can take, if you take further, they are made of elements. Elements. They are made of elements. Compounds and molecules are made of, example, protein is a molecule. Water molecule, macromolecule, DNA molecule, carbohydrate, protein, lipids, they all organelles means like say mitochondria, say nucleus. You can write example if you want. Organ and organelles don't mix up. Organs and organelles don't mix up. Organ means what? Say heart, lungs, they are organs, brain. But if you take organelles, if you can take here nucleus, mitochondria, say chloroplast, if you take plant cell, nucleus, mitochondria, cell wall, then that is until why did I highlight them green? You learn them under biology. You learn them under biology. So elements and the red one, elements and compounds, you learn under chemistry. So they are made of atoms. I'll write here elements, compounds and molecules are made of elements. Elements, even if you take elements, that is atoms, and atoms are made of the subatomic particles. Atoms consist of subatomic particles. So this part you learn under chemistry. That's what we are going to discuss under this lesson. Subatomic particles. What are the subatomic particles here? Proton, electrons and neutrons. Proton, electron and neutron. I put P for proton, E for electron, N for neutron, like that. So this red one, so actually we are going to discuss under chemistry. Elements, atoms, subatomic particles, compounds and all. So anything other than this matter, anything else, so that things, anything else found around us, we call it energy. So around us now light energy should be definitely available. We are looking at the screen, light energy. You get my sound energy. So that is energy. Energy you learn under physics. That's how actually the science divided into these three areas. Okay, then shall I raise this? Did you all finish copying down this? Anyone still copying down this in the writing book? Please raise the hand. Everyone should maintain a separate CR book to copy down this flow diagram, short notes. So that will be very useful when the exam is close. Exam is not only the term test, oral exam. Remember, don't forget that until 2023 December, whatever you write here, whatever you are copying down here, so that will be useful not only for the term test, for your O-level exam in 2023 December. That means you have to save you have to keep this for 2 years until you finish your O-level. Therefore, you should copy down all the chemistry short notes in a separate writing book. So those who have done, please lower your hand because we have to move to the next part, structure of the atom. Now we are going to start from this elements and compounds. I told what? Elements and compounds and molecules, we call them pure substances. Pure substances. So that's what we are going to discuss under this lesson. Okay. Now I'll erase the screen. Then you can see, I told you there are atoms are made of what? Subatomic particles. So highlight the, if you want to get a highlight, I have already highlighted here, but if you have got a print out like this, black and white, you can write here subatomic particles. Subatomic particles. Subatomic particles are found inside the atoms. Atoms consist of these subatomic particles. Okay, so simple P proton, E electron, come to the next blank, E electron, N neutron, simple N. Don't write the capital letters, simple. So these three are these subatomic particles. Atom consists of these three, and the location also I have shown here. So example, electron around the nucleus. So what is nucleus? Nucleus is at the center of the atom. In an atom, the nucleus is at the center. Nucleus consists of two subatomic particles, P and N. So even these capital letters, normally when you write this in your writing book, because capital P for phosphorus and capital N for nitrogen. So therefore, usually we don't write capital letters for the proton, electron and neutron. We write simple letters, even though because it's everything that you download from the internet is not 100% correct. So they are here, they are going simply, electron they have gone simply, but proton and neutron, that is capital letters, but that is not 100% correct, right? Now, actually these three subatomic particles was discovered by scientists with various experiments, with a lot of effort. Actually all three subatomic particles were not discovered simultaneously. The first discovered subatomic particle was electron. Actually, now these days if you take in a wire, when you connect battery to a wire and a lamp, then current flows. When you switch on the lamp, current flows through the wire to the lamp. Actually current means flow of electrons, electric current. So this electron is linked with electricity, electric current, electron. So therefore electronics. So this electron is the most important subatomic particle out of these three, because even in chemical bonding, electrons involved. Right? Electric current, electrons are flowing. Therefore, electron is one of the very important subatomic particle which is involved in chemical bonding, chemical reaction, electricity, conductor of electricity, electric current. And that is the first discovered and subatomic particle by a scientist called J.J. Thomson. You have to remember this name for the MCQs, I'll erase the upper this one. Let's see that this table. This table is not given in your textbook. This table is not given in your textbook, grade 10 chapter 3. This is very easy to study then, because MCQs they can ask me. Electron and symbol is E. Why this 0 and minus 1? Minus 1 for the charge. This corner and the upper end, the superscript, we put the relative mass. The relative mass of the electron is 0. R mass means relative mass. Actually, electron has a mass, but with compared to the proton and neutron, its relative mass is 0. Here relative, that's why it's called relative to the others, it's 0. Otherwise, actually it has a mass. If you want to write down that mass of the electron is not 0, but relative to the other two subatomic particles is 0. Example, if you take proton as the earth, electron like an ant on the earth. So earth does not feel the mass of the the weight of the ant, something like that. If you consider the earth as the proton, or proton is equal to earth, electron is like what? Like an ant on the earth. So that's why the mass of the electron is not considered even when you take the total mass of an atom. Now next one. Okay, so therefore discovered by whom? J.J. Thomson. They will not ask you to write this in the essay or structure, but important for the MCQs. MCQs they can ask. Even A-level paper, the first MCQ they can ask this. Then what is the relative charge? Relative charge means what? Electron is negatively charged. This is we call relative charge minus 1. Electron relative mass 0, relative charge minus 1. So what is the negative? If you want to write in your writing book, right? In your writing book, right? Please put a stand right in your writing book. The lightest subatomic particle is electron. Please write that, everyone. The lightest subatomic particle in an atom is electron. The lightest, look at the screen. The lightest subatomic particle is electron. Now remember, I will be discussing the chapter 2 physics, all the theoretical questions and the textbook exercise within next few weeks. But anyway, I am planning to start your paper class most probably either beginning of March or first week of April, either first week of March or first week of April. I'll let you know that at the end of this month, because chapter wise, unit wise, from 1982 2020 O level, 2020 O level, you have to discuss at least last 30 years papers. You have to answer from unit wise. Say unit 1, so grade 10 unit 1, all the MCQs and essays and structured essays from 1980s at least up to now, all the MCQs. Once you complete unit 2, you have to answer all the past MCQs last 30 years from unit 2. Like that, you should do a chapter wise revision also. You can't do all this when the oral exam is closed, because you have to do the model papers, past papers. So then you will not be having time to do unit wise one by one to do all the questions. Then only you will be fully okay. You will get the confidence to answer any question from that lesson. So that's what I'm planning to do the paper class. In addition to that, provincial papers, right, support center papers, and there are those are the work done in the paper class usually. I'll update you by the end of this month, right? Then what is the lightest subatomic? Please put a stand right, everyone in the writing book. Put a stand right. The lightest subatomic particle is electron. The lightest subatomic particle, right? Electron. Simply, this is very important. Lightest underline. It's lightest subatomic particle, that is electron. Then the other most important thing, what are the oppositely charged guys? Oppositely charged particles, you can see a electron negative, proton positive. So you can write the next point, you can write oppositely charged subatomic particles. Who are oppositely charged? Oppositely charged particles are oppositely charged subatomic particles will be proton. I put P and E. Protons and electrons are oppositely charged. Protons and electrons are oppositely charged. So you can hear +1 and -1. Neutron, neutral. So it's very easy to name. PP, proton positive. PP, proton positive. NN, neutrons neutral. Neutrons neutral. NN, neutrons neutral, uncharged. Protons positively charged. Neutrons neutral, uncharged. Is that clear, everyone? Then the remaining one is electron negative. So what is the first discovered? If you want to write that also, all three subatomic particles were not discovered at once. First discovered subatomic particle electron. So later, then second discovered one proton. First discovered electron, second proton, and later, thirdly they discovered the neutron by James Chadwick. Name important, or sometimes we call it E. Rutherford or J. Chadwick sometimes, right? So you can see they are approximate, not 100%. These two are equal in mass. Protons and neutrons are equal in mass. Therefore, sum of the mass of an atom depends on the mass of the protons and neutrons, not electrons. And the last two cages we have to complete here. So proton and neutrons, the position. Actually, electrons are not at rest. Electrons, just like it's like similar to planets revolving around the sun. Electrons are revolving around the nucleus, just like planets are revolving around the sun. The same person who discovered the proton. Who discovered the proton? Ernest Rutherford. Right? Actually, he specialized in physics. I think he was a professor in University of Cambridge or Oxford, as I remember. Therefore, those names are still there. Actually, most of the names in your science textbook, even grade 6, 7, 8, 9, right? English names now. Like you don't get like Kamala, Vimala, Sumana, like that. Those names there. Most of the English names, plus out of those English names also, most of them the males, right? Not females. Very few female scientists like that appears in your textbook. So most of the, even these people are English people. So John Dalton, right? Isaac Newton, right? Then Albert Einstein, or like most of them are male scientists. Even the recent like the Stephen Hawking, right? Then right now let's complete the last two cages blanks right here. Protons are found inside the nucleus. Protons are found inside the nucleus. Inside the nucleus. Nucleus is at the center, right? And neutrons also, right? Inside the nucleus. Inside the nucleus. The location inside the nucleus. Understood? Inside the nucleus. And here also inside the nucleus. Right. Done? Don't need to memorize this, but anyway, like when the exam is going to refer this, because if you get MCQs like recalling the past memory, previous memory, right? Recalling the previous knowledge. That's why, because of instead of giving a long paragraph, I gave like this because it's easy to cross-reference. It's easy to study when the exam is closed, right? Easy to refer the note. Okay, I'll erase the screen now. Then next one. After the discovery of these subatomic particles, scientists, they created various models of the atom. Right? So one of the most accepted model, like there were many models, but most of them were rejected, right? With the discovery, because some people they created model after the discovery of electron, right? Example, after the discovery of electron. After that, then only the electron atom is made of only electron, they thought. So later they discovered the proton also. Then that previous model was discarded, right? Then those things you are not discussing under grade 10 syllabus. How it is like gradual, like science means like kind of it's evolving. No, what to learn today can get invalidated by tomorrow. You have to continuously update your knowledge. Otherwise, you will be having the outdated knowledge. Out of all the subjects in the world, the most frequently updated subject will be science. Even now, a lot of research, right, innovations, and with that, new knowledge is added to this subject, and the outdated knowledge sometimes, if it is disproved by some person experimental, then we don't consider that again. We will take the new one, something like that. Now, proton, with the discovery of proton, again, I think there's a model called Plum-Pudding model. They are not mentioned in your textbook. That was by J.J. Thomson, the person who discovered the electron, but he created a model. That was discarded after the discovery of neutron. After the discovery of neutron, the previous models were discovered. Like that, now the most accepted one was, out of all those models, was presented by this is the person who called Rutherford, Ernest Rutherford. If you want to write below this this one, this is the image of this E. Rutherford. E means Ernest, right? E. Rutherford. E. Rutherford. What he gave this model, the name was given as planetary model. Why it is called planetary? His model, or sometimes we call it solar model or nuclear model. If you can put a slash and write, this is also known as solar model or nuclear model of the atom. Why solar model? He told Rutherford, electrons like planets, right? Nucleus like the sun. Just like planets revolve around the sun, electrons are orbiting around the nucleus. That's why we call it planetary model. Sometimes we call it solar model, or sometimes you can put a slash right here. Sometimes we call it nuclear model of the atom. Nuclear model. So he stated that nucleus is at the center here. Right? Protons and neutrons are collected to the center of the atom. We call it nucleus. Nucleus. Mass of an atom is confined to the center. That is called nucleus. The negatively charged electrons, look at the screen, negatively charged, highlight the word negatively charged. Remember your O-level science paper based on the grade 10 and 11 syllabus, not from the 9. Up to 9 you can, don't need to worry. That's why even I am not teaching the grade 9. I am teaching only 10, 11 and above A-level. So negatively charged, who is negatively charged? Now you know this. Electron, right? Come to the first blank here. According to the Rutherford's atomic model or the nuclear model, negatively charged, come to the first blank, electrons. Negatively charged electrons are revolving around the positively charged nucleus. Nucleus is what charge? Positively charged. Nucleus is positively charged. Positively charged nucleus. Positively charged nucleus. Negatively charged electrons are revolving around positive. Why nucleus is positively charged? Because of protons. Protons are positive. That's why the nucleus is positive. Similar to the planets revolve around the sun. That's why we call it solar model or the planetary model. Since electrons revolve, this is the other most interesting thing. Now electron is very light and is negative. Electron is negative. Sometimes you can argue, so why it won't get attracted to the positively charged nucleus? Because nucleus positive because of proton. Why nucleus is positive? Because of protons. Because neutrons anyway uncharged. Can you all please write here? Nucleus is positively charged due to the protons. Please write that everyone in the writing book. Nucleus is positively charged. Are you all writing? To understand the theory note, sometimes I'll give additional point in the writing book, or here itself if you have space in the writing the theory tutorials you can write down separately. Nucleus is positively charged due to the presence of proton. Please write it. Nucleus is positively charged due to the presence of protons. So negative. This is like in one drawback of the Rutherford theory is like he called these orbits. Orbits. Okay. Did you all did you miss anything? Okay. I'll repeat again. nucleus is positively charged due to protons. Nucleus is positively charged due to protons. Protons in it. Right? Protons are inside the nucleus. That's the reason. Then, but now what did I explain here? Electrons very light, negatively charged, protons positively charged. Why don't they collide? Why electrons do not fall onto the nucleus if they are opposite charge attracts, but they don't collide with the nucleus. I don't know. Do you have how many of you have seen? I don't know how many of you have seen this something called in carnival fest. Like when we were small, we used to say something called Markalindo or something. A person is riding a bike here. Please raise the hand those who have seen this person is riding a bike here around this like this. He is moving. This in the people are watching this. People are around this well. So the people this person is riding a bike inside this well on the wall of this well. In Sinhala we call it Marakalinda. Carnival and musical. They use this. They charge and the small ones they look at this. So he is moving fast on the wall. So suddenly can he apply brake and stop in the middle? No, he will fall to the bottom. So this electrons also like that, they don't stay at rest. They are moving rapidly around the nucleus. Otherwise, they will fall onto the nucleus. Since electrons are revolving, even planets are now. Are you at rest? You might say, oh, yes, I am at rest. I am sitting on a chair. Right? I am not moving anywhere. Physically, the things around you, also the room and the wall and the cupboard and all, you think they are at rest. Actually, the whole. Now you are not at rest. You are moving. Why? Earth is revolving now around the sun. Plus, Earth rotates around its own axis. Now we are moving. But we don't see that relative to each other. Since everything moving. It's like what? If you keep an ant on the football and if you are slowly turning the football to left or right side, ant will think, I am in the same place. No change. Something like that. Okay. So therefore in your body is what consists of full of elements. When you are born, say average birth weight say about 3.5 kilos. Now you are more than 35 kilos. 10 times. Why? You have collected so many elements to your body. When you are eating, you are collecting elements to your body. When you are drinking, you are collecting elements to your body. So you take those elements from the environment, from the nature, with food and drink, whatever you eat. So those elements are remain inside your body. Now sometimes elements you release, even now you are releasing. What is the element you are releasing now? Say oxygen. Carbon dioxide. Carbon and oxygen you exhale now. Water vapor, exhale air content, water vapor. Hydrogen and oxygen present in exhaled air. You exhale gases. So that means you are dumping some elements that you have taken to your body. Even when you pass urine, you pass hydrogen and oxygen as water, minerals. Therefore, most frequently we are dealing with whom? With the elements, not with our even family members. Remember that the most closest friend to your life is what? Elements. That means even gases around us. Right. Now, so chemistry is one of the very interesting subject, but if you learn it properly, if you get the basics, so this is the first lesson on the chemistry. So you get the, because it's get better like, sometimes if you, not in all the schools, some schools, if they don't teach this properly, then you will tell chemistry is very difficult. So very difficult to change that attitude after that. Therefore, what matters here, whether the subject is becoming hard or easy, depends on the way you learn it and based on the teacher. Right. Now it all, see, even though they are oppositely charged electrons and protons, they don't collide or they don't, electrons are not fall into the nucleus since electrons are revolving fast. Now even your body, electrons are there now. Your body is made of elements and atoms. So those electrons are revolving like this. But the only thing is, can we see electrons through our naked eye? Can't. Can we see atoms through our naked eye? Can't. Even under electron microscope, very difficult. Can't see. And can we see these even the chemical bonds? Oxygen, have you ever seen one oxygen molecule? Have you ever seen one water molecule? You can see drop of water, you can see glass of water, but have you ever seen even under light microscope one water molecule, H2O? No. You can't see even under electron microscope. Using nanotechnology like of atomic force, very advanced. I don't think we have, even in Sri Lanka, maybe one or two in the University of Colombo, some Peradeniya, but even they might not have this very advanced microscope like tunneling microscope or scanning electron microscope and atomic force microscope. We call it AFM, atomic force microscope. You can visualize the atoms. Other than using normal electron microscope, or even you can't see the atoms and the chemical bonds. They are so small, so many times smaller than even a virus. What are the best example? When you use the mask, right? COVID-19, you are wearing a mask. Virus, sometimes virus bacteria cannot penetrate or cannot enter through the mask, but gases pass, oxygen passes through the mask, otherwise you will die without oxygen. That means who is smaller, virus or oxygen? Oxygen molecule is smaller than even the virus. That's why oxygen can pass through the mask, but not virus or bacteria. Okay, then next one. So you should have this common understanding rather than just memorizing the text. Then they do not fall to the nucleus. Positively, right here, positively charged nucleus. They don't fall to positively charged nucleus. Why? Because they revolve fast. Highlight on it, since electron revolve very fast around the nucleus. So that's in the Marakalito, that one also the people are. So that person, if you ask him to stop suddenly in the middle of this well, no, he can't do this. He will slow down gradually and come to the water, right? So otherwise, if he now I'll give one of the example. When you are in a vehicle, right? When you are in a vehicle, it's like planet. The vehicle is moving. Vehicle is moving, say example 100 kilometers per hour. You also have the same velocity. You also have the same velocity. But you think you are at rest. Actually, you are not at rest. You also moving. One of the best example, when the vehicle is moving, if you jump out of the vehicle or out of the train, you will be thrown out of the road because you are jumping with high velocity. Can you suddenly jump out and stand? Can you suddenly stop? No. So therefore, when the vehicle or something is moving, if you are jumping out of the vehicle, you will be thrown out because you have a velocity. Remember that. So then later, after Rutherford, there was another scientist who supported this Rutherford's idea. So please highlight this scientist, Niels Bohr. He further, explained this Rutherford model. What he told, like electrons are not just revolving like planets in orbits. Electrons are moving in definite path. So Rutherford, it's like orbiting. Electrons are orbiting around the nucleus, but rather Niels Bohr told they are not just orbiting like planets. That's one drawback of the Rutherford model, but anyway, it's very close to the current model. Move in definite path called shells or energy levels. Complete the first blank. Definite path of the electron around the nucleus of an atom called definite path around the nucleus of an atom is known as definite path. That is called energy level or shells. Complete the first blank. Energy level. Energy level, or you can write shells. Energy level. Or shells. Right, energy levels, or those parts are called energy levels or shells. Look at the screen. Right. Done. Please raise the still copying down. Shall I read this? So therefore, after the discovery of subatomic particles, scientists they wanted to find how they are present, or the location. How do they exist inside the inside an atom? Where do they exist? How do they exist inside an atom? Inside an atom, how these subatomic particles are present or their behavior. So for that they created various models, or we call them model. Not model can change, right? That's why the early models were rejected. So actually it was improving. So we call them atomic models. and atomic models. After the discovery of subatomic particles, atomic models, but you are not given all the atomic models presented so far. You are given the most closest atomic model to the current or the most accepted one, planetary model. By whom? By Ernest Rutherford. So therefore you can write in your short notebook, Ernest Rutherford or E. Rutherford connected with two discoveries or two informations in chemistry. One is discovery of the proton. The second most important connection with the Rutherford in chemistry is discovery of planetary model or nuclear model of the atom. Number one, discovery of proton. Number two, planetary model of the atom. Okay, now I'll erase the screen. Right. Okay. Then let's see where do they revolve. Okay, example now. Okay, before I come to this, let's see. Okay, one more thing. I'll show you this very useful website about you also. If you are interested, you can use it. Give me a second. I'll show that. Can you all see the screen? You can see the screen, right? What is this called? This is called Royal Society of Chemistry website, the periodic table. And if you want, you can search it. Look at the URL, rsc.org periodic table. RSC means Royal Society of Chemistry periodic table. You can download the periodic table also. I will share that if you want with your WhatsApp group. Now you can see this periodic table. This is the long form of the periodic table, full periodic table, but you don't need to remember all this. If you look at LE say hydrogen, they'll tell everything. Configuration, density, the ionization, some information about hydrogen. If you put a lithium, they'll put it. In addition to that, you can visualize some of the elements in detail. I'll tell visual element images. So, or else you can metals, non-metals you can get separately. So if you click on metals, you can see only metals will be highlighted in this periodic table. It's very like interactive. Non-metals, then if you click non-metals, only non-metals will be highlighted here. Can you all see the screen now? No need to memorize. So it's you can using your mobile phone, no smartphone. Even now you can check. If you take non-metals, so if you take here group 1, then only group 1 will be highlighted. If you click on group 2 metals will be highlighted. Group 2 elements. So how many groups are there? There are 18 groups. Right? So if you take, there are 4 blocks here, S block elements. If you click here, P block elements, D block elements, the middle, F block elements at the very bottom. So there are 18 groups here. If I click on 18th group, that's what? Noble gases, helium, neon, argon, krypton, xenon, radon, like that. So period, first period. So you can see the second period, second row elements, third row elements, fourth row elements, fifth row elements, like that, sixth row, like that, seventh row. There are 7 rows. They are called periods. These vertical columns are called groups. Vertical columns are called groups here. Vertical columns are called groups. And this there are 2 rows at the very bottom because they are not directly connected to the main periodic table, because if they insert this also in the middle, the periodic table become horizontally very lengthy. That's why it's given at the bottom separately. That is called F block elements. F block elements. Right? Now even you can get more information. You can register in this website. Or I think then if there are some videos and there are historical background of these elements. There are a lot of other information you can get here, right? You can let's see here. If you take the temperature, if you want, you can check with the temperature what elements become. So here, when you increase the temperature, some elements become liquid. Physical state change. So this is also very interesting. Adjust the temperature now. What is the temperature? 547. Okay, I'll make it around. So in Colombo, the temperature is around 30 Celsius. I'll increase the temperature up to about say about 25-30 Celsius. Right, 71. Look at what elements. Some elements become liquid, right? So this is also very interesting. I'll make it 30 Celsius, 25-30. So at 25 Celsius, that's called room temperature. At 25 Celsius, you can see what are the liquid ones. Mercury is a liquid. Hg means mercury, right? And Br is bromine. And these green ones are gases. All the pale blue background, they are solid at room temperature. in Kelvin 298, in Celsius 25 Celsius degrees Celsius. Therefore, in online platform there are many benefits like this. You can't do this in the whiteboard or the blackboard, right? So if you adjust it, now what happened in Colombo, this mercury is a liquid metal. If you can write here, mercury is a liquid metal and bromine is a liquid non-metal. Bromine is a liquid non-metal. If you click on bromine, they'll tell everything here. Everything around bromine. History, uses, properties. If you click on uses, they'll tell you uses here. Right? If you move down, many things you can find here. Biological role, natural abundance, bond enthalpy. Even they put a video clip about video around bromine, about bromine. Right? Like that only. So therefore, you can like that you can find many things about this. If I click on say oxygen. If I click on oxygen, they'll tell everything about oxygen. Melting point, period, block, atomic number, many informations about this. Density, relative atomic mass. So even discovery, also history about oxygen they'll give. Atomic data, enthalpy, even until university level there are many informations. So you can use this website. You can if you get the assignment from the school or something like that, then you can do those things also. They have given the references also, right? So each element you can find separately one by one like this, right? Okay, those are the information. And even you can the temperature thing you understood, right? So it's if you increase the temperature, because it's some even the others can get melted at high temperature. So if you take sometimes in during winter, in cold climate, some of the elements can become even solid. Mercury can turn in very low temperature, very low, minus degrees Celsius. So minus 43. So then chlorine become liquid. No, the mercury becomes solid. Right. But anyway, you don't understand everything, all the symbols here. But anyway, this is what I want to remember. What this periodic table? Hydrogen is the first element. Wait. Look at the screen now. Hydrogen is the first element of this periodic table. This is hydrogen. Atomic number 1. Number 1 means it has only one proton. So this hydrogen also consists of proton, electron and neutron. Hydrogen is the first element. It consists only one proton and one electron. That means one positive charge and one negative charge. Therefore it's neutral. The net charge is 0. Any atom is electrically neutral. Why? An atom is electrically neutral because it has equal number of protons and electrons. Can you please write that in a short notebook? Please write that, everyone. An atom is electrically neutral. Please write that. An atom is electrically neutral. An atom is electrically neutral. Electrically neutral. Why? Because it has equal number of protons and electrons, equal number of positive charges and negative charges. I will write in the writing book. Please write that. An atom is electrically neutral. That means you are neutral. Your body is made of atoms and they have equal number of protons and electrons. So an atom is electrically neutral because it has equal number of protons and electrons, equal number of positive charges and negative charges, equal number of protons means what? Positive charges. I'll write here within bracket positive charges and negative charges, positive charges and negative charges, positive charges and negative charges, equal number of positive charges and negative charges. Wait, I'll write here protons, I'll close bracket here, positive charges and negative charges, and negative means electron is negative charge, equal number of protons and I'll write here electrons within bracket negative charges, Neutrons are chargeless, uncharged. Neutron even 1000 neutrons, no problem. Why? Because it's uncharged. What is the uncharged or neutral subatomic particle? Neutron. Neutral. Very easy to remember. Proton, positive, PP. Right. Then next one. Shall I erase this? Did you all finish copying down this in your writing book? Anyone still copying on this? So example, if you take an atom like this, if you can make a small sketch here. If you take an atom, if there's one proton, it's one electron, right? That is say hydrogen atom. If you take I'll take the oxygen atom or carbon atom. So carbon atom, it has 6 protons inside the nucleus, and it has nucleus has 1 proton. Hydrogen atom, this hydrogen. If you take oxygen atom or carbon atom, any other atom, and you can take any atom, number of protons equal number of electrons. So if you take carbon, 6 protons and 6 electrons, so it's neutral. 6 negative charges and 6 positive charges, neutral. Net charge 0. Not only any other, but from atom to atom, protons, electrons will change. From atom to atom, proton mass will change and the electron proton number will change. Okay, so that's you can. Okay. Then next one, I'll erase the screen. Did you all finish copying down? Right. Now next most important thing is this. Okay, if you take an atom, sometimes atom can become positively charged also. Let's see how an atom become positively charged. Let's see. Look at the screen, everyone. Now in an atom, in the periodic table, the atom, all the atoms like neutral, they have gone neutral. But an atom can become positively or negatively or neutral depending on the number of electrons and protons in it. Look at the screen, everyone. And everyone should, it's better if you can have a CR book. Chemistry separate CR book until your O level, the short notes. Because those things you will not get in your textbook. Right. Now let's look at the screen. An atom can become what charge? Neutral, positive or negative. Right. Look at the screen, everyone. An atom can become neutral. An atom can become neutral. Right, neutral. Please, at the same time, please copy down this. Otherwise, at the end you will raise the hand. So I'm still copying down. Then while you are listening to this, you can copy down. You can look at the screen. Neutral, or it can become positive, or it can become negative also. Some atoms can become negative. How? An atom can become positive, negative or neutral. Any atom should come under one of these. I'll give one example. Neutral means what? Number of, look at the screen, everyone. Neutral means number of protons equal to the number of electrons. Positively charged means there are more protons, more positive charges than negative charges. Remember, neutrons will not affect the charge. Neutrons will not affect which subatomic particle. If they are equal, it's neutral. If one is more than the other one, it's become protons more positive. If electrons more, I'll put the other way around. If there are more electrons in an atom than protons, it's negatively charged. Now I'll give an example. Okay, this is also very important. You can write down this under neutral one. This one more protons. I will copy down, everyone. Right. Please note down this. I'll give example for this. Example, if I take example, I'll write one example for this. If you take hydrogen atom, I'll write H here. So I'll write sodium atom. If you take sodium, if you take neutral atom, in the periodic table, the sodium, they have got Na. So I'll write here, say, you are familiar with this name. Carbon, say carbon is neutral atom. Carbon, why is become neutral? It has 6 protons. Carbon is the 6th element. Therefore, it has 6 protons and it has 6 electrons. Therefore, neutral. Therefore, neutral. So, equal. But if you take sodium, atomic number, the sodium is the 11th element. If you only can check the periodic table, sodium is the 11th element. So, it has, if you make a Na plus, that means what? It has lost 1 electron. That means why is plus here? It has 11 protons, 10 electrons. Who is more now? 1 extra proton than electron. Which one is more? Protons. How many protons extra? 1 extra positive charge. That's why the plus. If you write here 2 plus, 2 extra proton than electron. So why it's become positive? Because it has more protons. It has more protons. Why this one is neutral? Because it has equal. If protons equal electrons, neutral. If protons more, positive. Then the last one, if you have heard about sodium chloride, common salt in the kitchen. So Nl plus and Cl minus. If you take chlorine, chloride, Cl minus. So atomic number, I'll tell this, the order you have, remember the chlorine is the 17th element. Chlorine is the 17th element. It has 17 protons. 17 protons. Then electrons should be more than this, right? Because it's negative. Electrons, if electrons also become 17, I have to erase this minus sign. I have to erase this. But since it is minus, electrons should be more than protons. So it has 18 electrons. This is how you decide whether an atom is positive, negative or neutral. How? Someday you must be wondering. So how do we know whether it's how come 17? How come 11? How come 6? So that is the atomic number. That means number of protons. So this corner we write atomic number. That is the order. First 6th element in the periodic table, carbon. What is this number called? Atomic number. It's like identity card of the element. That is a unique number. No other element in the periodic table has atomic number 6 other than carbon. Atomic number 6 only for carbon. So that is for the identity of this element. If you take sodium, what is the atomic number? You can't change the place also. Leftmost side bottom you write the atomic number. Leftmost side bottom. Left side bottom. Not the top. So what this is sodium also we write here. Atomic number is 11. Atomic number is 11. Atomic number is 11. What is atomic number? Atomic number and the protons always equal. Atomic number is nothing else. Number of protons. If there's 1 proton, atomic number 1. If there are 2 protons, atomic number 2. Right? So that's what we are going to discuss next. What is the unique number of an element? Atomic number. Atomic number is nothing else the number of protons inside the nucleus of an atom. So the first element in the periodic table, hydrogen. Look at the screen. I'll use this. Okay, look at it. What is hydrogen 1 here? Hydrogen atomic number 1 because it has 1 proton. Why helium atomic number 2? Helium, look at here, number 2. Why helium has 2 protons? Wait, I'll have the periodic table. I'll share this IUPAC periodic table. There's one more periodic table. We call it IUPAC periodic table. Look at the screen here. Look at the screen. This hydrogen 1, helium 2, lithium 3, beryllium 4. That means when the number of protons increases inside the nucleus, atoms become heavier. The lightest atom of the periodic table is the lightest subatomic particle, electron. What is the lightest atom? Lightest atom is hydrogen. Why? It has just 1 proton. Helium has 2 protons, heavier than that. Lithium has 3 protons. That's why atomic number is 3. Can you see this screen here? Periodic table. I will share this with you. Don't worry. Because when you search the word periodic table in the Google, you will get like trillion hits sometimes. So many images, but don't know which one is most correct. That's why this is the IUPAC means International Union of Pure and Applied Chemists. It's an international body, international organization where the any change. So that is the most internationally accepted one in IUPAC, right? International body. Like they only make any changes, amendments. So no one can go above them, right? Any changes in the periodic table. Then boron, boron atomic number 5. Why? It has 5 proton. Now you can see this number. Carbon, I told carbon 6 ne? Carbon 6th element. Why? Atomic number is 6 means what? 6 means it has 6 protons. Then if you take sodium, look at, see the sodium, whether the number I gave is correct. Sodium I gave the 11th one, right? Now here they have given in the periodic table at the top, but standard symbol when you write it, you can write here 11 left side bottom, the standard notation. 11th element is sodium. That means no other element has atomic number 11 other than sodium. It's like your name and surname or your NIC. No other person has the same NIC number. Whereas no other element in the periodic table has 11 protons other than sodium. Therefore, 11th element of the periodic table, sodium. Why number 11 comes? Because it has 11 protons. 11 protons. So example, this is the most abundant metal in the earth crust. What is that? Aluminium. Aluminium is the most abundant metal in the earth crust. You can see here. Aluminium, what is the whichever 13th element of the periodic table? Aluminium. Aluminium is the 13th element. That means it has 13 protons. 13 protons. At the same time, it has 13 electrons. If someone takes electron out of this, electron number decrease. Then it becomes positively charged. If one electron taken out, electron become 12. Protons, no change. So I'll explain why which subatomic particle can change in an atom, right? Those things also very important. Always is like periodic table. Periodic table means it's like your chemistry alphabet. If someone is going to study the chemistry without knowing the periodic table, it's like you are going to do English diploma degree without knowing English alphabet. Something like that, right? Something like that. Okay, then did you all finish copying down this? You know, still copying down this? What did I tell? Atom can be positive, negative, or neutral. Now, if you take, say, I'll give one example. Sodium, if you take neutral atom, sodium, when it's become neutral, atomic number 11, 11 protons, 11 protons, 11 electrons. So it's neutral. We don't write any charge here. No, it's neutral. We don't write any charge. But some sodium, what happens? Sodium will lose one electron out. If you take one electron out of sodium, then electron number changes. If you take the electron out, it becomes 10. If one electron is given out, then it's become 10 electrons. Then the problem is become imbalance. Charges are balanced. Now that's how. Remember, in an atom, protons and neutrons inside the nucleus, they will not change under normal condition. Which subatomic particle can go out of the atom? Only electron. Remember that. Even during a chemical reaction, electrons can jump out of the atom as well as can be added to the atom. If electrons are added to the atom, become negative, because electron is negatively charged particle. That's the reason. Adding is plus, but here what is added? Negatively charged particle. That's why we put the minus sign. Say example, chlorine. Chlorine, the neutral atom, 17 protons, 17 electrons. Neutral, equally number. Electrons and protons equal. But what happens if you supply one electron to chlorine? Electron number increase from 17 to 18. You add one electron to chlorine atom. Therefore, out of the 3 subatomic particles, which subatomic particle can jump out of the atom and can be added to the atom? Electron. Protons and neutrons at the center, they will never undergo any change. They can undergo changes only during nuclear reactions, but nuclear reactions or Nashtika Pratikriya, nuclear reactions not introduced to your syllabus. Even A-level syllabus, we are in local, we don't teach much because we don't have nuclear power stations, and but some countries they generate electricity from nuclear power stations, nuclear energy, nuclear bombs, nuclear weapons, nuclear power stations. So nuclear chemistry is a separate branch. You can become one day nuclear scientist if you do nuclear science degree. So nucleus does not undergo changes under normal condition unless it is a nuclear reaction. Therefore, in your syllabus, protons and neutrons will never change in an atom. Only electrons number can increase or decrease depending on that. Atoms can become positive, negative, or neutral. So example, sodium, it doesn't like to stay as neutral. It always losing electron that to someone. So example, this nicely matched. Sodium chloride. What is the chemical formula of common salt in the kitchen? Common salt in the kitchen is sodium chloride. How come? Sodium lose the electron, chlorine can get it. So then they have a relationship. That is sodium chloride due to the exchange of electron. Sodium can, remember the atoms, they are not just dumping electron to the surrounding. If an atom lose electron, there must be someone to gain it. So sodium atom, so they are opposite charge. Ne? Sodium and chlorine can combine nicely, become sodium chloride. They are oppositely charged. So the sodium has lost the electron. To whom? To chlorine. Sodium has decreased from 11 to 10. Chlorine has increased from 17 to 18. Otherwise they are neutral, equal. 11, 11, 17, 17. Now 11 become 10, 17 become 18. Why? One person lose the electron, the other person gain the electron. This guy gained the electron. Then there will be a chemical bond between these two. You will learn this later under ionic bonding in chapter 10 about this in detail. Therefore, electron is the most important subatomic particle, not only for making ions, not only for making bonds, not only for making reactions. So many other, even electrical conductivity because of electron. That's why electron is very, very important in an atom. Even there are electricity come from this electron. Otherwise, they can put some other word. Electronics start with electricity, electrochemistry, right? Electromagnetism, right? Electronics. All right. Now you understood the importance of now in the subatomic particle, electron, its properties, behavior, and all. Right? Okay. Did you all finish copying now this? Shall I read this? Anyone still copying now this? Done. So what you write now? Usually atoms are neutral. In the periodic table, its sodium is Na, but actually sodium exists as Na plus because a neutral atom unstable. Neutral atoms, some of the neutral atoms are unstable. We write the symbol Na, but actually it can easily become Na plus by losing the electron out. Okay. Now, this is how you can get questions in the exam. Anyone still copy now this? Shall I read this? Did you all finish down this summary in your writing book, everyone? Anyone still copy now? Please raise the hand. I'm going to erase this now. Done, right? Okay. You had enough time? Okay. Remember, this is how you can get a question in the exam from this. They will give in the exam, they will never give the real symbol sometimes. They will give XYZ. XYZ. I'm asking a question. I'm going to ask a question from you now before I finish the today's lesson. If you get this, then you are very good. Then you are fully okay. Up to now, what I thought, if you can give the answer for this. Let's see how many of you will give the answer for this. There are three elements. I didn't give the real symbol, hypothetical elements. Now I'll write here protons and electrons. Protons and electrons. I write here first one 8, 8. This one I'll write 12, 11. Okay, I'll write a different one. I'll write here 20 and 18. 20 and 18. This one write 18 and 17. Now my first question. Out of the elements X, Y, Z, which element is neutral? Who can give me the answer? This is how you can get the questions in the exam. Questions comes like this in the exam. Which element is neutral? Who can give me the answer? Only 4 students. I told how to find whether it's neutral or not. Right, I'll ask the answer from Usman, Batika, Rohini, Malitma, Tisavi. Very good. X is neutral. Very good. Now a second question. Which element is positively charged? Please raise the hand. Who is positive? Who is positive? This neutral. Neutral one is X. Positive guy. Which element out of X, Y, Z positively charged? This is how you can hero. Tisavi. Sesat.
Y.
Very good. Element Y is positively charged. Now my next question. Element Y has plus so, 2 plus so, 3 plus so what? What is the charge on element Y? Okay, element Y is positively charged. What is the charge on that? Compare with how many extra positive charges? Who can give me the answer for that? Whether it's plus so, 2 plus. Plus Y plus so, Y2 plus so, Y3 plus. That also you can tell by looking at the total number of protons and electrons. This is not given in your textbook under theory. But this is how you can get the question in the oral paper. Yes, I'll ask Kishon, Malitma, Tisavi, Rohini. Very good, excellent. It's 2 plus. Why? It has 2, look at here. It has 2 opposite charge, 2 extra positive charges. 2 extra positive charges here. Why 2 plus? 2 plus means what? 2 protons. 2 plus. Then Which one is negatively charged, and tell me the charge also. Yes, anyone can tell me that, because anyway the remaining one. Yeah. Malitma. Negatively charged one is Z. So what is the charge? Is minus. So this is one method they could ask question in the exam. Whether it's you can tell whether it's charged or uncharged, or whether if it is charged, whether it's plus or minus. This is how you can get the questions in the exam. Remember proton. Can you all please write in the in your writing book? Proton number is unique for a given element. Proton number. Please put a stand right in right book, everyone. Number of protons is unique characteristics of given element. Number of protons are unique for a given element. Number of protons unique, or proton number. Number of protons or proton number is unique. Unique for a given element. It's like NIC, unique. In UNIQUE. For a given element. For a given element. Therefore, it is used for the identity of the element. Therefore it is called a unique number. Unique for a given element, and it is called what number? Atomic number. Therefore, it is used for the identity of the element. It is used to identify the element. Identify the element. And it is called what number? And it is called atomic number. That proton number is called what number? Atomic number. And it is called atomic number. Because other two can change. Neutrons and protons are unique. Neutrons and electrons can change with the charge and all. Whether even with this charge, proton number no change. Whether it's neutral or positive or negative, the proton number will never change unless it is a nuclear reaction. It is called what number? Atomic number. Which number is unique for given element? Atomic number. Atomic number is nothing else, protons. Electrons can jump out of the atom, can be added to the atom. Neutrons also is not unique. Sometimes there can be two atoms with the same number of neutrons. There can be two atoms with the same number of neutrons. But proton number will never become equal in two different elements. Two different elements, proton number never become equal. Never. Oxygen, protons only 8. No other element in the periodic table has 8 protons other than oxygen. Carbon, proton number 6. Sixth element in the periodic table, carbon. Hydrogen, first element in the periodic table, atomic number 1. No other element in the periodic table has atomic number 1 other than hydrogen, only one proton. That's why proton is like your NIC, identity card of the element. Right. So I hope you understood what I told. That's now you can see each subatomic particle is very important. No, electron I told the importance to predict the charge. But it's more or less so, yeah. And protons for the identity of the element, we call it identity card, means atomic number. For you, the identity NIC. For humans, or the humans, it's NIC, right? But in Sri Lanka or any other country, they have an identity of driving license or whatever. But in case of elements, it's an atomic number, right? So they have put the elements in the periodic table according to the increase in order of atomic number. When there are more atoms, so it's become okay. Look at here the screen. Here you can see what if you take mercury. So let's see the jewelries. Look at the jewelries here. Silver, 47 protons. Look at here, Ag. This is the jewelry group. Jewelry groups. Gold, atomic number 79. Au symbol, gold. Then if you take here platinum, yes, platinum here, PT. Atomic number 78. So jewelries are very close to each other in the periodic table. So that means this one has 47 protons. That's why atomic number is 47. Platinum, but no need to memorize this, only up to the first. Only up to 20th element you have to remember for O-level. O-level syllabus only up to 20th you have to remember by heart. 1 to 20 you have to remember all the symbols. Otherwise you can't do chemistry. Please try to remember. You are not given the periodic table with the paper in the exam. O-level and A-level. Periodic table, not given. Calculators are not allowed. So without the periodic table you can't find the answers for the chemistry easily, right? So therefore you can see any element. So unique, mercury, atomic number 80. So you can 47, 79. So these are, that means platinum has 78 protons. Who is heavier? Gold is heavier than platinum. Platinum is heavier than silver because they are, you can see the atomic number increases with the number of protons inside the nucleus. So therefore always you have to be maybe familiar with the, I'll share this with your group, don't worry. Today after the class I'll share this periodic table with your WhatsApp group. Then you can take a printout if you want. IUPAC periodic table I'll share with your group, right? Okay, then it's almost 8:05. We'll stop for today. I gave the introduction to the third lesson today a bit in detail because this chemistry is a little difficult. So we had to start with the rest. We'll complete the note now next day about atomic number I explained, and how these subatomic particles are located in an atom. We'll be discussing atomic number I explained in detail. So that is the next topic. Next day we'll complete this. Right. Okay, then we'll stop for today. Good night and God bless you all.